We're looking at a $40 billion market wipeout today. And, I mean, the crazy part,
Yeah.
the trigger wasn't a corporate scandal, wasn't some massive earnings miss, or even a sudden regulatory crackdown.
Not at all.
It was an announcement by an AI startup that they finally figured out how to automate the translation of a programming language, created, get this, when Dwight D. Eisenhower was in the White House.
It is wild.
Welcome to the Deep Dive. We build these custom-tailored explorations for you, the listener, who wants to cut through the noise, skip the avalanche of jargon, and get straight to the core of what is actually moving the world.
Exactly.
You want the shortcut to being well-informed, and today we are looking at a scenario that genuinely feels like a sci-fi thriller playing out in the financial markets right now.
It really does.
We are basing today's deep dive on a fantastic, highly detailed piece published in the Times of India, dated February 27, 2026.
It's a phenomenal case study in disruption. I mean, what we're witnessing is a direct, violent collision between the foundational architecture of the global economy, which was designed in the late 1950s, and the absolute cutting edge of 2026 artificial intelligence.
Yeah.
You rarely see the past and the future crash into each other quite this literally, or, with this much money on the line.
Okay, let's unpack this.
Yeah.
Our mission today is to solve this multi-billion-dollar mystery. How does a 66-year-old programming language cause IBM, which is arguably one of the most entrenched tech giants on the planet, to suffer its absolute worst single-day stock drop in over 25 years?
Right.
We're talking about roughly $40 billion in market value just vaporized.
$40 billion in a single trading session. To understand the shockwaves of that, we really have to look at the catalyst.
The startup.
Exactly. Just a few days prior, on February 23, an AI startup called Anthropic dropped an absolute bombshell on the enterprise software world.
All right, so Anthropic announced a new AI tool they're calling Claude Code. And the claim is that this tool can essentially automate the modernization of COBOL.
Yes.
And for anyone who hasn't spent time in enterprise IT, COBOL is the ancient programming language running in the basement of practically every major financial institution. But Anthropic isn't just saying they can assist with updating it.
No. They're claiming Claude Code can translate COBOL into modern programming languages like Java or Python in a matter of weeks.
Weeks?
Which is the operative phrase there, right? In a matter of weeks. Historically, for a major bank or a government agency, moving off COBOL has been a multi-year nightmare.
Sometimes a decade-long nightmare.
Exactly. The fact that an AI can suddenly condense years of grueling, highly specialized manual labor into a few weeks of automated translation is what rattled the market so severely. It directly threatens a massive, incredibly lucrative pillar of IBM's business model.
Let's hold on that for a second, because I want you, the listener, to really visualize the scale of this.
Yeah.
Picture a relatively new, highly agile AI startup essentially kneecapping a legacy behemoth.
Yeah.
And they didn't do it by building a faster computer or a better server. They did it by solving a decades-old headache that IBM are currently getting paid very handsomely to manage.
My word.
But before we get into the market massacre itself, we really need to understand the headache. We need to talk about COBOL.
We do. So COBOL stands for Common Business-Oriented Language. It was created in 1959.
1959.
Yeah, to give you some historical context, it was heavily influenced by Flowmatic, which was an earlier language designed by the legendary computer science pioneer Dr. Grace Hopper.
And the funny thing is, according to the source, this was originally a U.S. Department of Defense initiative, right?
That's right.
They just wanted a language that could play nice across different hardware systems. It was quite literally meant to be a stopgap measure, a temporary fix until something better came along.
What's fascinating here is that this quote-unquote temporary fix became the invisible bedrock of modern commerce. It never went away.
It's everywhere.
Even today, in the era of generative AI and quantum computing research, COBOL is still aggressively doing exactly what it was built to do in 1959, which is processing massive batches of business data,
Right.
payroll, administrative records, and crucially, financial transactions. The statistics cited in the article are genuinely staggering. It's estimated that 95% of all ATM transactions in the United States rely on COBOL.
That is wild.
Yeah.
That means almost every single time you walk up to an ATM and withdraw $20, your request is being routed through code that is old enough to collect Social Security.
Spot on. And it powers 80% of all in-person credit card swipes.
Wow.
In 2021, the Open Mainframe project put out an estimate that there are roughly 250 billion lines of COBOL code still in active use across the globe.
250 billion.
250 billion. It runs the airlines, it runs the banks, it runs government agencies, and the vast, vast majority of those 250 billion lines are running directly on IBM mainframes.
Okay, but I have to play devil's advocate here. If it successfully runs 95% of ATM transactions, why is it considered such a massive liability today? Like, if it ain't broke, why is everyone so desperate to fix it?
Well, the code itself isn't broken. The ecosystem around it is. The core issue is talent.
Ah, the programmers.
Right. The pool of developers who actually know how to write, read, and maintain COBOL has been shrinking drastically for over a decade. Modern computer science graduates are learning Python, they're learning Java, they're building cloud-native apps.
Sure.
Practically no one is lining up to learn a 66-year-old language, and that talent drought has created massive, real-world pain points.
We actually saw a very public, very painful display of this during the COVID-19 pandemic.
We certainly did.
The article highlights how state unemployment systems across the U.S., which were running on ancient COBOL systems, were suddenly hit with this unprecedented historic surge in demand. And they completely buckled.
They completely failed under the load.
Right. You had governors going on television frantically begging for retired COBOL programmers to come out of retirement just to patch these systems so citizens could get their unemployment checks to buy groceries.
Yeah.
It was a glaring wake-up call about our technical debt.
And the private sector hasn't fared any better, by the way. Over the years, major banks have attempted these massive migration projects to try and break free from COBOL.
With mixed results, right?
Mixed is being generous.
Yeah.
Many of those efforts have been unmitigated disasters. They've ended in widespread service disruptions, massive cost overruns, and severe regulatory fines because they accidentally locked customers out of their accounts.
Ouch.
It is so notoriously difficult to migrate away from that the U.S. Internal Revenue Service, the IRS, only very recently began its transition from COBOL over to Java.
Which brings us to a really interesting contradiction. If it's this dangerous to rely on, and the people who know how to fix it are literally aging out of the workforce, why did the banks keep it around for almost 7 decades?
Because, simply put, it is exceptionally good at its specific job.
Okay.
The technical architecture of COBOL is what made it so sticky. It was originally designed with optimal versatility in mind, and it utilizes an English-like verbosity.
So it's readable.
Highly readable, especially compared to terser, more mathematical languages from that era like Fortran. But its ultimate superpower, the main reason financial institutions refuse to let it go, is its native support for large precision fixed-point decimal calculations.
Let's break that down for a second. Fixed point decimal calculations.
Yeah.
As opposed to what? Floating point.
Exactly. Most modern programming languages use floating point math.
Right.
Which is great for general computing, but can occasionally introduce microscopic rounding errors at massive scales. When you are a global bank processing billions of transactions a day, you cannot afford a rounding error of even a fraction of a cent.
That adds up fast.
It does. COBOL's fixed-point math handles large financial calculations flawlessly, natively, every single time. That reliability is why it became an impenetrable fortress.
Here's where it gets really interesting. Let's look under the hood of how this fortress is actually built. Because it is completely unique compared to modern code. It has a very rigid hierarchical structure.
It does.
It's broken down into divisions, which are then broken into sections, then paragraphs, then sentences, verbs, and finally characters.
It's highly structured, yes. And understanding that specific divisional structure is actually the key to understanding why an AI might be uniquely suited to untangle it. Every COBOL program comprises 4 main divisions. It enforces a very strict separation of concerns.
But how is it actually organized? I mean, 250 billion lines of code has to be a chaotic mess, right? Does it have a specific structure that makes it so stubborn to modernize?
It does. Think of a COBOL program not as a fluid app, but as a highly regulated manufacturing facility.
Okay, I like that.
The first division is the identification division. This is the mandatory name tag on the front door.
So just the basics.
Right. It requires a program ID paragraph, and it holds meta information. The author's name, the date it was written, and a brief description of what the program actually does.
Makes sense. A clear label right at the top. What's next?
Second is the environment division. If the first division is the name tag, this is the blueprint of the facility itself. It specifies the runtime environment and maps out the input and output resources.
Wait, so the code itself has to explicitly declare the physical hardware it's running on. Like, hey, you're running on this specific IBM mainframe with this specific tape drive.
Historically, yes. It has a configuration section that tells the system about the computer and compiler features being used.
That's crazy.
Now, modern compiler tools have actually made this configuration section somewhat obsolete because modern systems can infer their environment automatically. But it also contains an input-output section featuring a file control paragraph.
What does that do?
That maps the internal file names used in the code to the actual external physical files on the machine.
That sounds incredibly archaic today, but I guess in 1959 you couldn't take the hardware for granted. Okay, so we have the name tag and we have the blueprint. What's the third division?
The data division. This is the storage room. It houses all the definitions for variables, files, and constants, and it's heavily subdivided so everything has its place.
Like shelves in the storage room.
Exactly. You have the file section listing every file the program touches. You have the working storage section for variables that need to keep their values throughout the whole run of the program, like counters. Later versions of COBOL even introduced a local storage section.
And what does local storage do? The source mentioned it's great for recursive algorithms.
Right. Recursive algorithms, basically, when a piece of code loops back to use itself to solve smaller pieces of a problem, local storage allocates memory for variables only when a program is deployed and deallocates them when it terminates.
Ah, so it cleans up after itself.
Exactly, which makes that kind of looping much safer and more efficient. And finally, there's a linkage section that defines data passing from one program to another.
Everything is obsessively categorized.
Yeah.
Which brings us to the actual work.
Yes, the fourth and final part, the procedure division. This is the factory floor. It contains the executable code.
The stuff that actually does the math.
Right. And just like human language, it's divided into sections and paragraphs for readability. Paragraphs are collections of sentences, which are the smallest executable units. And each sentence starts with a COBOL verb, like move, display, or ADD.
So a command might literally read like an English sentence, telling the system to move data from one place to another, ending with an actual period.
That's the idea. And it uses components called clauses to modify those statements. For example, a picture clause written as PI93 tells the system that a specific numeric variable can hold up to 3 digits. It also utilizes iterative and conditional control structures. It uses IF and LSC structures for conditional logic, executing different blocks of code depending on the situation. And it uses a perform statement to execute a section of code a specific number of times, much like a loop in Python or Java.
Okay, but if it is so readable and if the syntax is practically English, why on earth is it taking human engineers years to translate it? Why couldn't they just use a basic find and replace tool?
Because of the scale and the human element. Which brings us pivoting right back to 2026 and Anthropic's Claude Code.
Right.
Anthropic's central thesis is that the real expense, the true barrier in COBOL modernization, has never been rewriting the syntax. Translating move to a Java command is easy. The massive, crippling expense is comprehension.
Comprehension.
Yeah.
Just understanding what the 60-year-old fortress actually does.
Precisely. When human developers try to migrate these systems, they aren't just reading code. They are spending months, sometimes years, just trying to map the millions of hidden dependencies and extract the business logic that was written decades ago by someone who is now 85 years old.
Wow.
Anthropic says Claude Code can map those dependencies across thousands of interconnected programs, document the workflows, flag the risks, and extract that business logic in weeks.
If an AI can make that deep contextual analysis fast and cheap, it fundamentally changes the economics of the entire enterprise software industry.
If we connect this to the bigger picture, it is an existential threat to a massive revenue stream. IBM earns recurring revenue not just from selling the mainframe hardware, but from the software licenses and the armies of consultants tied to these heavy COBOL workloads.
Hold on, why wouldn't IBM just build or buy their own AI to do this? Why is it a threat to them?
Because IBM's strategy was never really to kill COBOL. Their strategy was to modernize around it.
Oh, I see.
They wanted to connect these legacy systems to cloud applications and offer COBOL programs via APIs, basically building digital bridges so modern web apps could talk to the old mainframe. They wanted to keep the fortress intact, but build modern roads leading up to it.
Because keeping the fortress intact means keeping the rent checks coming in.
Exactly.
But if an external AI tool can suddenly analyze, map, and translate the entire fortress into Java for a fraction of the cost, bypassing the need for human consultants to manually decode it, That core pillar of IBM's business just crumbles.
And that is exactly why the market reacted with such violence, wiping out $40 billion in a single day. Investors looked at Anthropic's announcement, did the math, and realized the legacy gravy train might be derailing entirely.
And it is not just IBM taking the hit. The article describes a broader massacre across the entire software industry. This AI disruption fear is rippling outward.
It is.
For instance, major cybersecurity heavyweights like CrowdStrike and Datadog saw their stock slump as well.
Because the AI isn't just translating code, it's auditing it.
Right. As part of this same announcement, Anthropic unveiled a separate security scanning feature built directly into Claude Code. The market sees a generative AI stepping into deep cybersecurity analysis and vulnerability mapping, and suddenly, the traditional security giants look vulnerable themselves.
Yeah, the numbers are grim.
A major software exchange-traded fund, an ETF tracking the industry, has shed 27% this year.
A 27% drop in a major ETF is massive. The article notes that is the steepest quarterly decline since the 2008 financial crisis.
That's huge.
It's a profound shift in market psychology. Investors are dumping legacy tech names because the pattern is becoming predictable. An AI company drops a new capability that automates a highly complex, highly lucrative technical task, and the addressable market for traditional consulting firms, service giants, and enterprise software vendors instantly shrinks.
Wall Street is repricing the entire sector based on the assumption that human technical labor is about to be drastically devalued.
Exactly.
So what does this all mean? We started by looking at a $40 billion drop for a single company. But what we're really looking at is a paradigm shift.
A massive one.
The market has fundamentally decided that the era of expensive, multi-year legacy modernization projects that required massive teams of specialized human consultants billing by the hour is ending. It's over. The only debate left on Wall Street right now is just how fast the transition will happen.
And while the financial markets are entirely focused on the speed and the cost savings, this raises an important question, one that goes far beyond stock prices and touches on the stability of our institutions.
I know you have a thought on this. The source mentioned organizational inertia and undocumented business logic. Where does this leave the banks and the government agencies once the AI is actually done translating?
I want you, the listener, to really think about the reality of a 60-year-old code base. These COBOL systems running our banks and tax agencies contain 6 decades of human decision-making.
Right.
60 years of patches, frantic workarounds, and specific business rules written by human beings to solve human problems at specific moments in time. Maybe there was a weird tax loophole in 1984 that required a custom fix. Much of that logic was never formally documented in a manual. The code itself is the only existing record of why a system works the way it does.
The institutional memory is literally trapped in the syntax.
Exactly. So imagine this scenario Anthropic is promising. An AI perfectly translates 60 years of this undocumented, human-written business logic overnight into clean, modern Java. It compiles, it runs perfectly.
Sounds great on paper.
But the original human programmers are long gone. And now, the new code was generated by a machine, completely bypassing human comprehension.
The bank has modern code, but nobody at the bank actually understands why the code is making the decisions it's making.
Right. If something goes wrong 5 years from now, or a new regulation is passed, who understands the underlying logic well enough to safely change it? If we swap old human-understood technical debt for instantaneous AI-generated code, do we just create a brand new, completely invisible kind of risk? We might be fixing the programming language problem, but we could be entirely losing the plot on how our most critical institutions actually function.
That is a brilliant and honestly a slightly terrifying point to end on. You don't just translate a language, you have to translate the intent. And if the machine does it instantly, the human context might be lost forever.
Exactly.
Thank you for walking through this incredibly complex web with me. And to you listening, thank you for joining us on this custom deep dive. We hope it sparked some of those aha moments and gave you a new perspective on the invisible code running our world and the AI that is threatening to rewrite it. Keep questioning, keep learning, and we will catch you on the next deep dive.